Hello, this is Sai doing the math project. I did a related rate scenario and I basically modeled how fast a forest fire spread after an accident in the woods. And then I used calculus to determine how fast the area of the burning forest was increasing. So Bob and Jerry snuck out of Jerry's house during a sleepover and they wanted to light off fireworks in the woods. They each bought 3 mortars from a sketchy dealer earlier that day. And then they hiked into the middle of the woods, started a bonfire, and then because they're kind of dumb, they brought a can of gasoline to jumpstart their fire. And eventually they were like, let's light off these fireworks. So Jerry went first. He lit off a mortar and it blew up in the sky. It was amazing. It was an amazing firework. Look kind of like that. And then Bob wanted to go next, and Bob's kind of, a little clumsy. So when he set off his firework, it flew into the gasoline can, and then a giant fireball erupted and started a giant forest fire. So the firefighters modeled this fire as expanding outwards at a constant rate on all fronts, creating a circular boundary to the fire. This means that the radius increases at a constant rate. So you can see this is the radius at a certain point in time, and this is how much it's increasing at. So m equals meters, obviously, and then the radius of the fire is increasing at a rate of 1.8 meters per minute. Here we can write this as dr over dt equals 1.8 meters per minute. And then at this current moment, the radius is 190 meters, so r equals 190 meters. The rangers want to know how fast the area of the fire is increasing at the current moment. So we're finding dA over dt. And we're just writing all these down so that we can maybe substitute them in later. So firstly, because the fire forms a circle, we can model the area of the burning region using the formula A equals pi r squared, just like this. And now, since we have that formula, we can now differentiate both sides of the area formula with respect to time. We can use the chain rule to do this, and the derivative of pi r squared is 2 pi r times dr over dt. So then we have dA over dt equals this. Now we can substitute the known values that we had at the beginning back into the equation. So that would make the new equation dA over dt equals 2 pi times 190 times 1.8. And then all we have to do now is simplify, and then we can find the area of the burning forest to be increasing at approximately 2,150 square meters per minute. And so this is our answer, and we can basically see this in Desmos. So this is at 0 seconds before the fire started. This is 1 second, 1 minute, obviously. And then it increases the area increases exponentially. So just at 10 minutes, it's already gotten that much bigger. So we learned that the fire is expanding extremely rapidly and causing a lot of trouble for the firefighters. And Bob and Jerry got thrown in jail for 100 years because of it. And so, the related rates basically can explain how critical it is to have an extremely fast response to a forest fire. Now Ethan is going to go over the optimization problem.
Now it is time for the optimization problem. So, Ethan wants to build an underwater fortress for his family. He has the materials, the interior structure, the location, the permission to build the fortress, and the overall structure. A couple days pass by and Ethan begins building. He puts in the door, the windows, couches, beds, kitchen, and the game room into the fortress. Everything was all set and ready until his mother asked one final question. Ethan had used a Norman window for his fortress, and his mother loves those types of windows. "My favorite child, this looks great, but I noticed that the total perimeter of your Norman windows is 20 feet. So, what are the dimensions of your normal window of maximum area since the total perimeter is 20 feet? So, Ethan got straight to work and began solving these equations. So, he first established the formulas and also established that the radius is x over 2. So, as you can see, he first set everything up, then he began solving for the perimeter by setting it up as 20 equals x plus 2y plus yx over 2. So the first step that he needed to do was begin solving for the y. So he moved everything to the left to get 2y by itself. And then he began finding a common denominator for those fractions, which resulted as 4. So now it became 40 minus 2x minus pi x all over 4. Now that Ethan has found the y, he plug it back into that area function and also put in the radius, which is x over 2. So he began multiplying them together, and then he multiplied the right side by 2 over 2 to get that common denominator of 8. Once he got that, he combined them, and that resulted in 160x minus 8x squared minus 3 pi x squared all over 8. The next step for Ethan is to now find the derivative. So with that equation he found previously, he now found the derivative, which resulted in 160 minus 16x minus 6 pi x all over 8. He then began simplifying that equation, which resulted in 20 minus 2x minus 3 pi x over 4 equals 0. Now he has the final step. He must now solve for the x. So he first put the numbers with x's on the right side. So which was 2x plus 3 pi x over 4 equals 20. Ethan then factored out the x. And then he divided 2 plus 3 pi over 4 on both sides to get that x by itself. And the final result became 20 over 2 plus 3 pi over 4. So Ethan's final answers are 40 minus 2x minus pi over x all over 4 as the length, and 20 over 2 plus 3 pi 4 as the width. Thank you for watching.